system properties. Okay, so system properties, there's not much question can ask, just this kind of questions. Okay, linear, time variant, memoryless, causal. That is the always question come out. Is this signal is linear? Is this signal is time invariant? Is this signal is causal? So you just need to prove that. So how do you want to prove that the signal is, the system, not the signal, the system, because the system properties. Okay, is this system is linear? Is this system time variant, memoryless, causal? This is the only question we have for this chapter. Okay, so we look for the first example. Okay, so you are given the system. I say this is system because it has in equation output and input. So this is not signal, this is system. Okay. All right. Actually, I'm not sure whether if you check for the textbook, they may have different methods. But the most important thing, I want to know whether the system is linear or not. So I have, this is what I understand, the methods, how to prove that the signal, or how to determine whether the system is linear or not, time invariant or not, memoryless, causal. Okay, so first we check for the linearity or linear. So with this system, yt equals to 2 pi xt. So the question asked is this system linear? Or determine the linearity, means that you have to have the conclusion at the end, this is linear system. Or if you find that this is not linear, so you have to have this conclusion, the system is not linear. That is the answer. Okay, so how we prove that, how we show that? Okay, so we have this. Okay, so just follow the steps. Okay, so you have the system yt equals to 2 pi xt. So I just copy back the system. Okay, and then I write y1 equals to 2 pi x1t as equation 2, and then y2 equals to 2 pi x2t. So to check for linearity, so you have this homogeneous and additive. So remember, if you have system, so if you have input xt, so you will have yt, right? So if you have system x1t, so the output will be y1t. So if you have x2t, the output will be y2t, right? If the system is homogeneous, so you will have ax1t, here you will have ay1t, right? Okay, if the system is homogeneous, if you have ax2t, the output will be ay2t, right? If the system is additive, so you have x1t plus x2t, so you will have y1t plus y2t. Okay, so this is additive, so this is homogeneous, this is homogeneous. All right, so now if the system is homogeneous and additive, which is linear, so you should have this. So you should have this. So this is the combination ax1t plus bx2t. The output is ay1t plus by2t. So this one I combine both homogeneous and additive, so into this is linear. Okay, so that is the block diagram for that. Okay, so you write these three equations. Okay, 1, 2, 3. This is the first 3 steps. Okay, so if you have linear system, so this will be your input, ax1t plus bx2t, and the output from the system is ay1t plus by2t. So this is the input, so that I can write as xt. So xt equals to ax1t plus bx. So this part I take from here. Okay, and then the output YT, so this part I take from here. So that is your fourth and fifth equations. All right. Okay, so how to prove this? Okay, so this equation 4, right, you substitute into equation 1. So you have xt here, right? So you have xt here, sorry. So you have xt here. So you have here xt. So substitute equation 4 into 1. So what you see this, okay, 2 pi. So this is your xt. So 2 pi, this comes 2 pi xt, right? So xt is from, this is from equation 4. So, and then you arrange this, you will see that you will have a 2 pi x1t plus b 2 pi x2t. So this part, 2 pi x1t and 2 pi x2t is your equation 2 and 3. 2 pi xt, 2 pi x1t, 2 pi x2t. So you substitute that 2 and 3, equation 2 and 3 into 6, so you'll have this. So you see, and then you check. If you obtain this, after you substitute equation 2 and 3 into 6, so you obtain this form, which is same as equation 5. So means then the the system is linear. Okay. If you check if you substitute the equation 2 and 3 into your 6th equation, and you didn't have, you have your 7th equation, and your 7th equation is not equals to equation 5, the system is not linear. Okay, so just follow the steps. That is how to prove whether the system is linear. So in this case, your equation 7 here equals to equation 5. So in the block diagram, thus the system is linear. So that is the I think the easiest method how to show, to prove that. Okay. So any signal you can apply with these steps. Okay, just if you have other signals, so here should be other signal. I mean, just the steps are the same, exactly the same. All right. Okay, Arvin Raj, anything to ask? Or just okay, I think nothing from Arvin Raj. Okay, so that is for linear. All right, linearity, and then time invariant. Okay, so again here, this is how you show that the system is time invariant. Okay, so time invariant is if you have system xt, the output is yt, right? If the system is time invariant, you have xt minus t naught. So your yt should be yt minus t naught. So this system is said as time invariant. So how to prove that? Okay, so you are use the same signal, same system here. All right. So write the equation 1, 2, 3. So equation 1 is actually the system. All right. And then write equation 2 and 3. So if you have y1t, so your will have x1t. So if you have y2t, you have 2 pi x2t. Okay. So write these 3 equations. Okay, so this is because time invariant, so dealing with times delay, right? So if you have x to t, and x to t is assumption that we made. Okay, so if you have x to t, your x to t is x1 t minus t naught. So the signal x1 that have delay with t units, t naught units. All right. So x2 is actually x1 that is delayed. Okay, so x2t equals to x1t minus t naught. Okay, so you substitute this equation into equation 3. So you will have equation 3 now become this equation 5. So y to t equals to 2 pi. So this is your x2, right? x2t. So because your x2t is x1t minus t naught. So you substitute that 4 into 3. So you have this equation 5. Okay. And then take your, okay, leave it this equation. Okay, take your equation 2, right? Take your equation 2. All right. So you do time delay on that. Okay. So you do transformation, t transform into t minus t naught into equation 2. So you will have 2 pi x t minus t naught. Okay. So when you see this, you have another new question, that is equation 6. And then you compare equation 6 and 5. If equation 6 equals to equation 5, means that the system is time invariant. If not, the system is not time invariant. Okay. In this case, I give you example time invariant. Some system you might have this not equal. So when 6 equation not equal to equation 5, so the system is not time invariant. But in this case, 6 equals to 5, so the system is time invariant. So we have example, the example for this script, we have the not time invariant. Okay, so just follow the steps, easy. So this is how we just want to prove. Okay, any signal, you can apply for any signal for time invariant. Okay, and then you have to check for memoryless. Based on the definition, we know that if the output of the system depends on the pass input or pass output, which the pass input or pass output is written by t minus, so they have xt minus t naught. Xt minus t naught mean x t minus 2, minus 3, minus 4, or depends on the pass output, t minus 1, y t minus 3. So minus here show already happened, pass. Is you have y t plus 1, so this is future. So in this case, memoryless, to check whether the system has memory or not. Okay, so if the system has memory, it has to store whatever happened in past. Okay, yes. Okay, so in this case, you have yt, the system output depend on the input at the present time. Present output here depends on the present input. So it does not depend on the past, whatever happened in past, either input or output. So means that the system is memoryless, no memory. Okay, just look at that. Okay, if you have yt equals to 2 pi x, 2 pi xt minus 2, yes, the present output depends on the past input, t minus 1. So this system has to store the past input, so it has memory. In this case, no. Okay, I hope you're fine with that. And then causal, okay, causal also based on the definition, if it depends on present and past, it's causal. So in this case, present input output now depends on input now or input at present times, so it's causal. Okay, so this is check by the definition. This one is easy, just based on the definitions. Okay, and then we have another example. for this time around, you have the discrete, okay, system. So to show the system time invariant, the same step you use for the continuous time system. Also linearity, so you will use the same steps, no different at all, okay, just follow the steps. So in this case, the signal is discrete, the system is discrete because this is output and this is input. So the relationship between output and input, so this is systems, right? So just follow the same, so you will have yn and then y1n, y2n, right? Okay, so if your x2n is x1 having delay by n naught, so your x2n, because here we have n over 2, right, here. So x2n, so equals to x1 n over 2 minus n naught. Okay, so means that that signal having that delay. So this equation 4, you substitute in equation 3. Okay, so you will have this x n minus 2 minus n naught. So this is your, because you're x2, right? x2, so x2 equals to x2 n over 2. So this is your, so x2, so this is your x2 n over 2. So substitute that. Okay, so you see that your y2n is x1 n over 2 minus n naught. Okay, so leave it equation 4 as it is, and then go to equation 2, do time delay, where you have to transform n to n minus naught. So you will see that this part you will have n change to or transform to n minus naught. Okay, so and then you compare equation 5 and 6, you'll see that they are not the same, they are not equal, because equation 5 is n over 2 minus n naught, equation 6 is n minus n naught, all this divide by 2. So they're not exactly, it's not equal. Okay, when this is not equal, so the system is not time invariant, or another way we can write is time variant only. Time variant, or not time invariant, or you can write not time invariant. Same. It's not equal. All right. And then last one is again to check for memoryless. Okay. So to check for memoryless, in this case, because you have this form n over 2, so the easiest way is to change to use any value. So if n now is 2, okay, so if y2, so x is 2 divided by 2, so 2 divided by 2 is 1. So means that if the output at t equals to 2, so it depends on the input at t equals to 1, which is pass. Depends, okay, this is pass, okay, because it's already happened, right? So in this case, the system has the memory. Okay, so you can check for that. Okay, so this is the only question we can ask for system properties, to check for causal, to check for memoryless. Okay, that one is just based on definition. If for time invariant and for linearity, you can use the methods here or the steps here to prove that the signal is linear or not linear, time invariant or not time invariant. Okay, so we've done that. Okay, and actually I have upload all the answer for you to check. Okay.